Hello, in this short video I investigate the following problem. Determine an equation for the tangent to the curve y equals to square root of x minus 1 over square root of x at x equals to 4. Pause the video at this point and give it a try. Okay, so if I want to find an equation for the tangent line, I have to calculate the slope of the tangent line. To calculate the slope of the tangent line, I have to differentiate my function and then replace x in the derivative with the x-coordinate of the point of tangency. Okay, so I will do that. But I have to prepare this function for differentiation. So I will do this. Instead of square root of x, I would write x to the power of 1/2. I will do the same thing here. Still, it is not ready. I bring it up, so it becomes x to the power of 1/2. The first one I copied and pasted, and when I bring it up, it becomes x to the power of minus 1/2. Then I can simply differentiate. So 1 over 2 goes down, x to the power of 1 unit less. 1/2 minus 1 is minus 1/2. This one, minus 1/2 goes down, minus becomes plus 1/2. X to the power of minus 1/2 minus 1, which becomes minus 3/2. Okay, that is okay. Differentiation is finished, but I prefer to put them with positive exponents and use the surd sign as much as I can. This symbol that you see, some people call it radical, but that's also called a surd sign. So what I will do, I would write 1 over 2, and I bring this down, it becomes x to the positive 1/2, and then plus 1 over 2. I bring that one down as well, so it becomes x to the power of positive 3/2. But now I can write it as 1 over 2. Instead of x to power 1/2, I simply write square root of x. But this one can be written as 1 over 2, the second root of x to power 3. Okay? Because I am using this formula, the nth root of a to power m is equal to a to power m over n. So here x is playing the role of a, 2 is playing the role of n, and 3 is playing the role of m. So that's correct. But this is my derivative. I have to calculate my derivative at the x-coordinate of the point of tangency. This number is called is the k-value of the tangent line, t for tangent. So I will go here, replace x with 4. So it becomes 1 over 2 square root of 4 plus 1 over 2 square root of 4 to power 3. 4 to power 3 is 64. So it becomes the square root of 64. That's very simple. Square root of 4 is 2 times 2 is 4. So it is 1 over 4 plus square root of 64 is 8. 8 times 2 is 16. So it is 1 over 16. I can't take the common denominator to be 16. 16 to 4 4 times. 4 multiplied by 1 4. 16 to 16 1 time. And then becomes 1. So this becomes 5 over 16. So I realize the k-value of the tangent is 5 over 16. This is the k-value of the tangent. But I also need the y-coordinate of the point of tangency. But if I want to calculate the y-coordinate of the point of tangency, let me call it y0. Y0 is just your function calculated at the x-coordinate of the point of tangency, which in this case is given to be 4. So this means that I go back to my original function, replace x with 4. So this becomes square root of 4 minus 1 over square root of 4. But this is simply 2 minus 1 square root of 4 is again 2. But 2 minus 1/2 becomes 3/2. Okay, so what I have, this is my k, this is my y0, and x0 is the number given from the beginning. And then if I want to write a formula for the tangent, this is the standard way of writing the formula for the tangent. Yes, y minus y0 equals to k times x minus x0. Of course, this is always true if x0 and y0 is any point on my line and k is the k value. Okay? So I replace y0 and x0 with those numbers and the k with the k value of the tangent. And I probably need to simplify it a little bit. So instead of y0, I put 3/2. Instead of k, I put 5/16. And then I have x minus x0, which is 4. I prefer to simplify because usually it is common to have y on the left and everything else on the right. So I would say that y is equal to, I move minus 3/2 to the other side, so it becomes plus 3/2. And then I multiply 5/16 in, so it becomes 5/16x. And this one multiplied by that, it becomes minus 4 and 16 are simplified, so it becomes 5/4. Then I can combine these two numbers by taking the common denominator. Let me do it here. The common denominator is 4. 4 to 4 one time, so it is minus 5, and then 2 times, so it becomes 6. So the answer is simply a 1/4. So this means that y is equal to 5/16 times x plus 1/4. So this is an equation for the tangent line to that curve at the point on the curve whose x coordinate is 4. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.